Chapter 4, Fraction Mask. I'm almost done with teaching you everything I know about creating your own hex filtration chart. Technically, you already know enough to easily build a chart one row at a time, but that's not good enough for me. This chapter focuses on a strange and somewhat advanced technique to build your hex chart one column at a time. In fact, doing it this way, you can build one column or heck, even just part of one, and then build each row backwards and forwards directly off of that. What a fun and exciting idea, don't you think? Hey, don't groan. I heard that. Let's see, where should I start with this? You know what? How about we take a quick look at chart number 3A? If you couldn't already tell, this chart does not have any hex digits on it, yet each number you see accurately represents a specific hex digit at any given point for any row. The observant person might recognize a certain similarity between this chart and the hex filtration chart we've been working with since the beginning of this book. Each row on this fraction mask chart starts from an ever-increasing column number value, just like the hex chart. The row and column numbers themselves are just like the hex chart, and even the numbers on the chart continue on into infinity, just like the hex chart's digit patterns do. Of course, these numbers won't repeat like the patterns of chart number 1A. All these similarities are deliberate. They make it possible to do everything that makes this chapter great. In fact, I personally consider this technique to be the best way to build the hex filtration chart because of the ease with which you can start from any column and never have to build the complete pattern for each row. That's much easier, if you ask me. The equations are very simple and straightforward. Let's say you look at an old base 10 number, and then you want to check and see if it has a prime value. Let's use the number 501, for example. Well, mainly because it's a fun reference to a certain popular movie franchise I won't mention, and a very cool looking brand of jeans. Okay, so we want to determine if 501 is prime. What do we need to figure out first? Well, from what we learned in previous chapters, we need to determine which column this number belongs to. You should already know how to figure this out with ease. 501 minus 1 divided by 8, blah, 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 blah. It's the same calculation from chapter 1. The result, of course, is 62.5. But you can drop the decimal for this. We just need the column number for this exercise. So the column is 62. Now what? Well, we want to use this number to calculate the next number digit below it in the column. Think of each number below the column heading as a separate unique digit that represents a hex digit you could find on the hex chart, because this is exactly what this all correlates to. Just to be clear, or maybe a bit confusing, I guess, we are calculating the column's number digits in this example by starting at the top of the column, and then we will be working our way down to the last digit placed at the bottom of the column. However, we could have just as easily started from the bottom digit and worked our way up the column to its top column heading number. I'll show you how to do that in the next example when I'm done with this one. Anyway, to calculate down the column, we need to use the established column heading number we determined earlier. The number is 62 for those who might have already forgotten. And subtract it from the value of its row number plus 1. FYI, the row number for all the column heading digits is 0. So then the calculation is 62 minus 0 plus 1 equals 61. Simple as pie. This means that the row following the column heading digit, i.e. row 1, has a 61 to represent its associated hexadecimal digit. Next, using that 61 and its row number, we can calculate the next value. Put everything into the equation. 61 minus 1 plus 1 equals 59. This is so easy. Just continue this trend until you get to anything below 0. For good measure, here's all the numbers you will find for this particular example column. 62, 61, 59, 56, 52, 47, 41, 34, 26, 17, and 7. If you try to calculate anything further down past the 7, then you will be getting negative numbers, and you can't use negative numbers, so that's how we know 7 is the last number. Please be careful to note that sometimes the last number will be a 0, which is often considered to be neither negative or positive. Don't ignore this 0, however. It's just as important to the column as any other number on this chart. Well, I sure hope that my example managed to help you clearly understand the technique for calculating number digits while progressing down a column. As I mentioned earlier, I'm going to present another example. But this time I will show you how to calculate number digits starting from the last position in a column while progressing up a column. For this example, I'm going to use the base 10 number 429 to get things started. Please try not to get confused by all this number juggling. Remember that the base 10 numbers like 429 and 501 are not part of the set of numbers that make up each column. Just like the hexafiltration chart, these base 10 numbers are the ones represented inherently by each column's corresponding binary group, as explained in chapter 1. Since we don't know what the last number in this column is, we are forced to use our base 10 number 429. Similar in how we used the one in our previous example, except that the calculation for this one is a wee bit different. The first thing we need to do when calculating columns with this new technique is to figure out what the column's last row number is. Yes, I said row. I know it sounds weird, but trust me, this is how it works. You can do this by first finding the square root of your base 10 number, then subtract by 1 and divide by 2. Just remember to drop all fractions during the calculation. Thus, the square root of 429 is 20. Minus 1 and divide by 2 returns a row number of 9. Now that we know this, we need to calculate this row number times 2 plus 1 and square it all. You should already know how to do this from the previous chapter, so I'll just do it here. 9 times 2 plus 1 to the power of 2 equals 361. Alright, so what's the big deal? Well, the whole point of doing all these little equations is to figure out what the number value is for the digit place at the bottom of the column we are calculating. Well, I personally think it's simpler to use the technique I already showed you for calculating down a column, but I'm presenting this technique for those who might find some use in such unique approaches, and heck, why not be thorough? That's what this little book is all about after all. Finally, subtract the 361 value we derived from your base 10 number originally and divide by 8. Thus, 29 minus 361 equals 68. And 68 divided by 8 equals 8.5, which when we drop its decimal is the correct number for our column's last digit place. Okay, we can finally start calculating up the column from this number. You need only to add the row number to your column's corresponding digit value for that row. That's it. So we already know that the row number associated with the last digit of our column is 9. And we determined that its associated digit place number is 8 for our column. Add them together and we get 17, which is the digit place value for row 8. Now add 17 to its row number, i.e. 8, to get row number 7's column digit value of 25. Then you can easily take this all the way to row number 0 at the top of your own. But just for good measure, and because I'm feeling a bit generous, here are all the digit values going up the column from row number 9. 8, 17, 25, 32, 38, 43, 47, 50, 52, and 53. Now, to be thorough, let's check the math and calculate for the column heading number used in our initial base 10 number. As a quick reminder, we started with the base 10 number 429. But I'm not going to do this part for you. I expect you should know how to determine what column heading is from here based on what you learned in chapter 1. Please try to figure it out on your own. If anything, this should help you learn it better. But wait, yes, there's more. What we need to do now is figure out exactly which hex digit each of these numbers correspond to on the hex chart. It's easy to just find and use the remainder amount derived from taking a number digit in any one of the columns from the fraction mask chart. Whatever one you want, divided by twice the value of its row number plus 1. For the more nerdy folk, that is to say n mod 2x plus 1. All that is required now is a simple table check. No problem. Please refer to example chart number 3b. For any row except row number 1, a remainder value of 0 means that the number you checked is a hex 7 on the hex filtration chart for its position. Oh, okay, hold on for a second. Before I present the rest of the table, let me explain a couple of annoying algebraic things about it. I use the variable h in the table. H equals the row number multiplied by 2 plus 1, then it's all divided by 4. So just keep this in mind when reading the rest of this. Okay, so for odd rows except row number 1, a remainder value of h is a hex e. A remainder value of 2h plus 1 is a hex d. A remainder value of 3h plus 2 is a hex b. Any remainder value other than these on an odd row is a hex f, except when calculating row 1, in which case, if the value does not equal to a hex d or a hex b on the table, it is automatically a hex 6. Now for all even rows, a remainder value of h plus 1 is a hex b. A remainder value of 2h plus 1 is a hex d. A remainder value of 3h plus 1 is a hex e. Any remainder value other than these on any even row is a hex f. No exceptions. So, do you really need an example for these? You're a smart bunch. Surely you don't need examples for such simple. Oh, all right. Okay, I'll give a few just in case. Let's use numbers from column 12 on the example chart number 3a. Obviously, the first number in the column is its heading digit 12. But there's never any reason to calculate the heading number. It just helps keep track of which column we are in. As such, let's move on to the next number below it in the column. Since the heading number is always assumed to be an effective row number 0, then the next digit, i.e. 11, is obviously on row number 1. This we can calculate for a hex digit. 11 mod 2 times 1 plus 1 equals a remainder of 2. Now, on to check it with the table I showed you. Right away, we should know that it's not a hex 7, and it's also not hex E, mainly because, as I mentioned just before, this row number 1 has a special exception where if the remaining number is not equated to a hex D or hex B, then it is automatically a hex 6. As such, this row is the simplest one of all because we only need to check for 2 digits, not 4. So then, let's start. We need to check 2h plus 1. Well, it looks like we need to determine what the value of h is. As I've explained not too long ago, it's row number times 2, then plus 1, all divided by 4, which in this case is 0.75. I should point out that you need to always drop all decimals. We don't want them for this. Thus, h equals 0 for row number 1. Now we can calculate the value of 2h plus 1. It easily equals 1. And since I is not the same as the remainder value we have previously established for the second digit placed in this column, we know that our number is not a hex D. Next on the table, 3h plus 2, this should be easy, since we already calculated h as being 0. The result is an obvious 2, which is the same as the remainder we got. Thus, the digit for row number 1 in our column turns out to be a hex B. Well, how about that? I'm sure that should be enough for you to figure out the remaining digits in this column. If you're unsure, then don't forget you can still refer to the Example hex chart to check your work. Well, that's it. I've basically got nothing more to say except for now it's time to move on to the next chapter. I hope you enjoy it. Example fraction mask flowchart. For digits in a column found on an odd row. First, calculate the remainder from using digit value mod 2 times digit row plus 1, i.e. column 12, row 1 is 11 mod 2 times 1 plus 1. The remainder equals 2. Second, compare the remainder result with table 3b digit row. e.g. on table 3b for row number 1, the remainder result of 2 is a b hex digit. If the remainder result value for a given digit row is not found on table 3b, it's a f hex digit. Okay, exceptions. When calculating for row 1, if the remainder result is not found on table 3b, it's an automatic 6 hex digit. For digits in a column found on an even row. First, calculate the remainder from using digit value mod 2 times digit row plus 1. e.g. column 12 row 2 is 12 mod 2 times 2 plus 1. The remainder equals 2. Second, compare the remainder result with the table 3b digit row. e.g. on table 3b for row 2, the remainder result is 2 is a d hex digit. If the remainder result value for a given digit row is not found on table 3b, it's a f hex digit.